Hello, everyone. My name is Georgia Zalou.
I'm Josiane.
And this is the session called Speech Perception 1. It's Tuesday afternoon in Brno, Czechia. We'll get started with our first talk. Our first talk will be presented by Xiao, and it's Prosodic Disambiguation using Chironomic stylization of intonation with native and non-native speakers. Thank you.
Okay, well, hi everyone. Thanks for being here. So our line of research started off with the overarching question of how to control vocal synthesis expressively in real time using hand gestures, which we call chironomy, which comes from the Greek meaning with the hand, so chironomic stylization. This research was originally envisioned as a way to create new musical instruments. And at the bottom, there are a couple of examples. On the left is one of our collaborators who's singing a song with the handwriting gestures using a graphic tablet. And on the right is me playing the theremin. And I'm happy to talk to you at length about what instrument this is, but you play it with your gestures in the air without touching. And here I am singing a song.
Tu me prends dans ses bras, il me parle tout bas, je vois la vie en rose.
But this talk is not about singing, but all of this is made possible by a paradigm called Performative Synthesis, which we're using a vocal synthesizer called Vox, which was written in Max MSP. And the way it works is that you start off with a speech sample that's in monotone. So here I am recording something. You can also take an existing recording and flatten it. There's some manual work to label the syllabic regions for certain types of control. And when you actually control it, we're able to control the fundamental frequency, the vocal effort, and the timing in real time. So here is me playing what was just recorded. So as you can see, using performative synthesis, using the hands, we are able to not only sing melodies, but also reproduce the intonation of speech. And in fact, there was a prior study from some of our collaborators which showed that native speakers of French were able to replicate the intonation of example phrases using their voice and their hands with comparable accuracy. So for this study, they used the graphic tablet shown below, which controlled only the frequency, not the timing or the vocal effort, and there was no visual guidance. Now, for the current work, we asked ourselves whether non-native speakers can use the paradigm of chironomic stylization to practice the intonation of foreign languages. Now, we think that this might be interesting because chironomy targets some of the main pain points for learning the intonation of a foreign language. So first, it can train the ear to perceive unfamiliar sound features, where when you're learning a new language, you're not really oftentimes hearing what's actually there. And the correspondence, multimodal correspondence between the kinesthetic and maybe the visual with the auditory can help attune people's ears to new sounds. Second, oftentimes people get stuck with the intonation of their native language when they're trying to use their natural voice. And the idea of using their hands is a way to bypass these ingrained habits. And finally, it's hard enough as it is to learn the segmental level for a new language, and using a vocal synthesizer enables people to focus just on the suprasegmental level. So we designed a pilot study to continue in the footsteps of the prior work to look at the feasibility of using chironomy for intonation practice. So we were primarily interested in 4 questions. The first question is kind of replicating what was done before, comparing chironomic, gestural, versus vocal imitation of different phrases. And in addition to that, we also wanted to look at the effect of having a visual guide versus not having a guide, as well as having the addition of timing control in addition to just controlling the frequency. And of course, we're looking at not only native speakers, but also non-native speakers. So to do this, we designed a mobile interface that talks with the vocal synthesizer. So the vocal synthesizer Vox still lives on the computer, and that's what's outputting the sound. There's a Max MSP patch that's doing all the processing, and there's a server that mediates the messages between the synthesizer and the mobile interface. Over here, for the interface, it can run in a Chrome browser. It's written in JavaScript. It's a web app, so it's cross-platform. And as long as the device and the computer are on the same network, Wi-Fi network, it does the communication, and the sound comes from the synthesizer. So here is how it works, and we might need to turn the sound all the way up. Okay, well, the sound is quite low, but I'll explain afterwards what you're seeing. So basically, this is what the interface looks like, and the right section is the part that's doing the control. So the first thing that I did in the video was I pressed the yellow button to listen to the reference, and then in the control region, there's the y-axis, which controls the output frequency, the x-axis, which controls the phonemic content, and this is based on some syllabic labeling from a Pratt text grid, and the movement speed is what controls the timing of the utterance. So there are two modes for the gesture. So whenever you're dragging your finger across the screen, there's a trace that's left of what you did. When it's in pink, it's temporary and it fades away, but you can click the top button on the left, which puts it into held gesture mode. And here, the trace turns into dark purple and it stays, so that afterwards you can press the second button to re-listen to it and maybe compare it to the reference to see how you did. And then the two other buttons are to erase the gesture, to try again, and to save the gesture. So the yellow line, you might have seen, so there's a yellow line here, which is a visual guide, which sometimes appears. And this is generated from a program called Prosogram, which is a simplification of the raw F0 curve into straight line segments. And the reason we did this instead of showing the original F0 curve is because oftentimes when you take the raw F0, there's a lot of microprosodic details, and we don't want people to get confused tracing all of those. And so this just gives people kind of a rough idea of what the intonation looks like. In terms of the corpus, we went with a prosodic disambiguation paradigm where we had pairs of phrases that share the same sequence of phonemes in syllable segmentation, but they have different meanings based on the intonation of how they're pronounced. So the IDs are not in order because these phrases come from a larger corpus that was used in a class for non-native learners of French, and the reference recordings were recorded by a native female speaker. So more precisely, the difference in meaning is based on the location of the first prosodic word boundary, which in French is marked by syllable lengthening, by a rise of the F0, and sometimes by a small pause. So to give an example, we have the phrase on the left, there's Jean porte un journal, and on the right is Jean porte un journal. And this is what it looks like on the interface with some gestures. So as you can see here, the gestures don't exactly follow the curve or the reference curve, and this is because the reference is just to give you an idea. In the end, you can deviate a little bit from it, but as long as the general shape follows the right curve, it still sounds okay. And the lengthening or pause is expressed by the speed of the movement. So to make the two phrases look the same, the syllables for each phrase appeared with equal width. And so it's up to the people themselves to modulate the speed. So this experiment had 4 different tasks that was organized in 3 sections. The first section and the last section are vocal sections. So in the beginning, each phrase appeared on the screen and people had to read it based on their own interpretation. And in the end is a vocal imitation section where people could listen to a reference by pressing the yellow button, and they had to record themselves imitating the reference. The middle part is the chironomy part, or the gestural imitation part. So for each phrase, people had 2 attempts. Well, people had multiple attempts, but there are 2 setups for it, where in the beginning, they had to find the right curve without any help. And then after they submit one attempt, the visual guide shows up and gives them a bit of a guidance. And for each section, all the phrases appeared in a random order, but the pairs always came next to each other. And for all the tasks, the subjects could listen to the reference, listen to their own recording, repeat the trial until they were satisfied with what they did, or until they could no longer improve. And only the final trial was kept for subsequent analysis. In terms of subjects, we recruited 10 people, 5 non-natives and 5 natives. And keep in mind that this happened in February 2021. This happened in person. So we were unfortunately a bit limited in our choice for subjects, but nobody got COVID. The non-native subjects were recruited through a class on French pronunciation, and they had a special pass to come in person to do the study. Everybody resided in France, and their level was quite advanced, but their mother tongues, as you can see, is quite varied. And the native subjects were all undergraduates in speech therapy studying in France. In terms of the analysis, we followed the existing work and took 2 curve comparison measures. So all of the stimuli collected were extracted, the F0 curves were extracted, converted to semitones, and we used weighted Pearson's correlation and root mean square error to compare the subject's curves with the reference curves. So correlation basically tells you how similar in shape 2 curves are to each other, where 1 is the best, 0 is no correlation, and -1 is the worst. And root mean square error gives the average difference. So a higher score actually means a worse imitation. And we are primarily interested in comparing 2 types of things. So looking at previous work, we tried to kind of retrace their footsteps by looking at vocal imitation and chironomic imitation with no timing. In here, we chose guided because in general, guided did better than non-guided. So we took the best attempt of chironomy and compared it with vocal imitation, first without timing. And then to assess the role of the visual guide, we compared non-guided versus guided, this time with timing. And the difference between timing and no timing kind of enabled us to get an idea of the effect of that condition. So looking at the scores in aggregate, on the left, there are the scores organized by phrase, and on the right, the scores are organized by types of subject. So just at a glance, we can see that when we don't take timing into account, so the red and the green scores are actually quite high across the board. When we do take timing into account, the scores are lower or are worse, but guided chironomy consistently do better than non-guided. But in order to see whether there's any significance, we made some Bayesian multi-leveled models. So in the paper, it talks about different types of models that were used in model comparisons, but just the one that we settled on is one that models score, which we had to transform to get Gaussian distributions. The score is a function of the condition, the nativeness, as well as their interaction, plus random intercepts for phrase to take into account that phrases could have different difficulties, and random slopes for subjects based on condition to take into account that different subjects might perform differently in different conditions. So 4 models were created for the different types of scores and for different pairs of conditions to see the effect. So we looked at vocal versus gestural no timing and guided versus non-guided gestural with timing. Here are the posterior numbers from the Bayesian multi-level models, and what's in pink is what is significant. So it's parameters with entirely positive or entirely negative 95% credible intervals. And to explain what you're seeing here with respect to the questions that were presented at first, so when we look at vocal versus chironomic imitation, they performed comparably, which is similar to what the prior work reported. Vocal did show a slightly better imitation, but and only in RSME and not in correlation. But it's actually a very small difference, because if we look at the intercepts reverse transform back into the original numbers, we see that the average difference is just around 1 semitone, which is quite negligible. So even though vocal did slightly better, it's only very slightly. And also vocal imitation was the last task, so there could also have been an effective practice. But we do see some more pronounced effects when we compare visually guided versus non-guided imitations. So guided perform better than non-guided. And if we look at the effect of timing control, so looking at the analysis with timing taken into account and without, we see that with timing, the scores are a bit worse. And this was something that the subjects also reported. So they all said that it was a bit difficult to control the timing by dragging their fingers. Surprisingly, though, we didn't find any significant difference between native and non-native speakers. However, I'm out of time, and anyway, we did this tiny online perceptual pilot study, and we did find a few differences between non-guided or between non-native and native subjects, and more specifically for vocal reading, there are some phrases where the non-native subjects made some mistakes, and for those phrases, the guided chironomy performed significantly better. And so, based on all of these results, we can safely conclude that chironomy, especially guided, can be envisioned as a way to help non-native speakers practice intonation. But we should think about easier ways to control timing, and in the future consider more perceptual testing, and if the situation in the world allows, find less advanced subjects where we can maybe see more improvement. Thank you very much.
We have about 4 minutes for questions. Questions from the audience? I don't see any questions online. Yes, in the back. There's a microphone up in the front, I guess. I think so too, yeah.
Really fascinating work. I was wondering if you control for people's motor skills in some sense, that people might differ vastly in their ability to
Yeah. Yeah, so that's a really good idea. And one thing that we did look at, what we collected the data for, is whether people have musical experience. And we didn't have enough subjects to really say anything significant about it, but kind of the working hypothesis is that if you are a musician and if you're used to doing interesting things with your hands, with sound, then people do better. But it is definitely something to consider for the future.
but singers might not be so good at using their hands.
Yeah. Yeah, well, so for musicians, it's
It was like playing an instrument.
yeah. So the question of musicians, it's actually also more complicated than that, because I think on the one hand there's motor skills, but there's also ear. And I think one of the ideas here is, like, if you're already good with the auditory motor connection, then you're going to be good at, playing this new instrument. For people who aren't already so good with that, we think that the visual guide can be very helpful. But yeah, motor ability is a really important thing to consider.
Can you please ask the questions to microphone, because people who are online cannot...
Oh, sorry.
Do you hear me?
Yeah.
So what is, can you tell us a bit about the J&D for pitch in running speech?
The J and D?
Like just noticeable difference.
Just noticeable difference. So I looked at some papers, and I think it talked about differences less than one semitone being not really so perceptible. So yeah, but I haven't done a comprehensive exploration of that. But if you have references to suggest, I would love to hear them.
Would you think it makes sense to take into account the J&D in your error measure?
Certainly, yeah. I think it's a good suggestion for the future.
Thank you.
Yeah.
No, it's okay. Okay, just...
If we have time for one more question, I'll ask it. So what you demonstrated in the tutorial that you showed in the very beginning was you using your hands like this. Am I correct?
Yeah.
And then what you had the participants do was a finger draw on the iPad. So I wonder if you could just talk a little bit about those. So those seem like different modalities, with sort of in your hands, in the air with your hands, versus a finger draw. The finger draw seems easier, but the hands in the air seems kind of more intuitive. Maybe you could talk about those differences?
Yeah, sure. So what I showed in the beginning was, honestly, it's a side project that we worked on together where it's with controlling singing with the theremin, which is a musical instrument that you play. There are antennas that detect the distance between your hand, which on the one hand controls the pitch and on the other hand controls the volume. And this is actually generally considered to be a very difficult instrument, but I'm kind of obsessed about it. And so it's my hobby to play this instrument. In terms of using the theremin to teach intonation, it's certainly imaginable, but we decided to go with the mobile interface because, first of all, we don't expect everybody to have theremins, and kind of the long-term vision for this project, if you will, is imagining whether an app for your iPhone or for your mobile devices can be developed where people can practice these things. And there is like either using your finger or using a stylus. And so that determined the choice of that interface. What I showed in the beginning was just it's like the best videos that I had to show the capabilities of the vocal synthesizer itself.
Very cool. Thank you so much.
Yeah, thank you.
Thank you.